Morning, guys. Okay, this lesson is all about, this is lesson three, and it's all about logical operators. Okay, so one of the super important things that a computer has to be able to do is to answer questions. So in a program, we state something, and then depending on whether the result of that statement is true or false, the program will do something differently. You could imagine this, for example, we are dealing, this section of work that we're dealing with, all to do with microprocessors. So you can imagine, for example, the computer inside your microwave oven at home. It might be deciding if the timer is greater than naught and the door is closed. Then it can switch on the radio inside the microwave to start heating up your food. So those are two statements. Is the timer greater than zero? And is the door closed? So that's what we are going to be dealing with in this section. Okay. So I've got the notes open here. And you will know that in the normal algebra that you guys have been doing, right from lower grade 4 or 5 onwards, you have encountered some of the mathematical operators. And these are less than or equal to, greater than or equal to, and not equal to. Okay, so there are 6 relational operators that you get in standard mathematics, standard algebra that you guys have been doing for years already. Okay, so what we are going to be doing now is we are dealing with a different kind of operator. Okay, we're going to deal with what we call logical operators. So logical operators will allow us to join multiple statements together into a single statement. So you can read a little bit of the history here about what it does, and that's just for interest's sake. You don't have to know that. I'm not going to ask you in the test who is George Boole. Okay, so you can see that in elementary algebra, okay, you are used to dealing with numbers, 5 plus 3, or 4 is greater than 3, or something like that. Okay, but now when we deal with Boolean, okay, we are now working with 3 things. Okay, there are more than these 3, but we are dealing only with 3. That is what we call the AND. Okay, so we have the AND operator, we have the OR, and we have the NOT. So we've got AND, OR, and NOT. Okay, so let's deal with the AND operator first. So the AND operator allows us to join multiple statements together. Like you can see there, I've got expression A and expression B. Now, we can see that the AND operator is true. Okay, so the answer to an AND statement is true if both of its inputs are true. So the name kind of gives it away. Input A and input B must be true to get a true result. Okay, so all inputs have to be true to get a true result. That is an AND operator. And you can see there that some languages show it as 2 ampersand signs. You can see them here, these two ampersand signs. That's above the 7 on your keyboard. Okay, and we will be using that notation. Okay, so there is what we call the truth table. Okay, so if we have got 2 inputs, okay, we know that we have 4 possibilities. Okay, the number of possibilities is 2 to the power of how many inputs you've got. Okay, so we have got 2 inputs, input A and input B. 2 to the power 2 is 4. So there are 4 different combinations of inputs that we can have. If there were 3 inputs, so if I had expression C, okay, if I had expression A, expression B, and expression C, the number of inputs would be 2 to the power 3, which would be 8. Okay, but you don't have to worry about that. We won't use more than 2 here. So you can see from this truth table here that I've got obviously 0 is false and 1 is true. Okay, so that my output is false, okay, as long as some of the inputs are false. As soon as both inputs are true, okay, they are both 1. As soon as both inputs are true, the output is true, okay? So you can think back to where I said the microwave oven, okay, expression A could be timer greater than 0, and expression B could be door is closed, okay? So if the timer is greater than 0, it means you've pushed a time into it, and you've closed the door. Then the computer in the microwave oven can safely turn on the microwaves. Okay, it's not going to cook you because the door is closed. If one of those things was not true, okay, the timer was not set or the door was not closed, it would not start. Okay, because you've got a false here. That's just an example, and I've given you some other examples here. So you can see here, expression A would be 5 is greater than or equal to 7. We know that 5 is not greater than or equal to 7. Okay, it's less than 7. So that would be false. So we've got a false statement this side. Okay, and here we've got Bob equals George. Okay, so this here is checking to see if these two words are identical. And they are quite clearly not identical. So we've got false and false. 2 falses gives us a false. Okay, so the answer to that statement that we've made there is false. So let's look at this one. Okay, before we do this one, let me show you something else. Okay, so here I've just made you a short little number line. And what I'm showing you here is that every letter on your keyboard, the computer assigns it a number. Okay, you don't have to remember these numbers, but you do need to remember that A is going to be less than Z. Okay, capital A is less than capital Z. Capital A is given the number 65. Capital Z is given the number 90. Little a is given the number 97. And little z is given the number 122. Every single computer in the world uses those numbers. Everyone. It's a standard called the ASCII standard. So we know that A, big A, is less than big Z. Okay, we don't have to remember the numbers, just know that A comes first. Okay, so here, obviously, if we're doing an alphabetic comparison, A in Alice is less than B in Bob. So the answer to that statement is true. This first piece, Alice is less than Bob. And Alice is less than George. We know that is true as well because A is less than G. Okay, so we've got a true and a true. And if we've got two trues, the answer is true. Okay, so those are the ands. So basically what you do is you just evaluate each expression and then you and them together using this pattern. Okay, so let's go to the OR operator. Okay, the OR operator. The OR operator is another Boolean operator, okay, and we can use it to join expressions. Okay, so you can see where there we said expression A or expression B. Now the OR operator is a little bit different. Okay, remember the AND operator needed both inputs to be true in order to get it true. The OR is a little different. All you need is one. Both of them can be true, but at least one of them must be true to get a true output. Okay, and we use these two vertical bars. You'll find them probably near your enter key on your keyboard. It'll be on the top part, one of the top part of the keys, probably above the backslash or something like that. So you've got these two vertical bars. So here is the truth table for an OR. Okay, you can see if we've got two falses, the output is false. But if I've got at least one true, I just need one. Can be both, but all I need is just one, at least one. If I've got any one, okay, if any one of the inputs is true, the output is true. So that's how they're slightly different to the AND operator. And once again, the name kind of gives it away. Input 1 or input 2. Okay, if this or that is true, I'm going to get an output. So the name kind of gives it away. Okay, so if we have a look at the examples of that, okay, we're saying that 5 is greater than or equal to 7. We know that is false, okay, because 5 is indeed less than 7. Okay, so we know that that is false. Okay, and Bob equals George. Okay, we know that that is false because they are not equal. Okay, so we've got a false or false, two falses, still give me a false output. Okay, so the answer is false. Okay, let's have a look. The first statement says Alice is less than Bob. Okay, yes, capital A is less than capital B. So Alice is indeed alphabetically less than Bob. So that is true. Okay, as soon as I've got one true, I know I'm going to get true. I don't even have to evaluate this side. As soon as I've got a true, I know my output's going to be true for an OR. Okay, but let's check this side anyway. Is Alice greater than George? No, because A is less than G. Okay, remember on our number line here, A was 65, G is going to be in the middle here somewhere. So on this number line, there's A is 0. There's 0 on the number line. So definitely A is less than anything. Capital A is less than anything. Okay, so here we're saying it's greater than, so that is false. So we've got true or false. One true gives us a true. Okay, so that is the OR. Okay, let's have a look at the NOT operator. The NOT operator is very, very simple. It's basically just, it flips the input. Okay, so the NOT operator is used to perform logical negation. We call it negation. Okay, so we take input A and we make it into not A. So we just flip it. If it was false, it becomes true. If it was true, it becomes false. So here's the truth table. Okay, note there's only one input here, not two. Like with the AND and the OR, we had expression A and expression B. Here we've got one input and we flip it over. So there it's false, it becomes true, and on the output, and a true input becomes false on the output. So that's all it does. So here's two examples. Okay, 5 is greater than or equal to 7. So if we look at that there, we are saying 5 is greater than or equal to 7. We know that that is false, okay, because 5 is not greater than or equal to 7. Okay, so we know that the answer to that there is false, and not false is true. So let's look at this here. Bob equals Bob. Okay, does Bob equal Bob? Yes, the two words are spelt identically. You're looking at the spelling here. The two words are spelt exactly the same. Okay, if this one was in capital letters, this would not be true. Okay, they have to be exactly the same. They are exactly the same, so Bob does equal Bob, so that is true. The brackets is true. Not true becomes false. So that's all that not does, is it just flips it from true to false. Right. Now you will remember in mathematics, you did BODMAS. Okay, you did brackets of division, multiplication, addition, subtraction. You will remember BODMAS. That is the order in which you must do things. So if you've got a long equation in maths that's got a whole lot of plus, minus, divides, multiplies, that BODMAS tells you the order in which you must do things. Now with Boolean algebra, we have exactly the same thing. Okay, so you can remember it as BNAO, B-N-A-O, BNAO maybe. So it's not BODMAS, call it BNAO, B-N-A-O. So you always do brackets first. It's precedence, okay? We call this operator precedence. Even in mathematics, they might not have told you, but that's what it's called. It's called precedence. It's the order in which you must do things. So brackets, you always do brackets first. always, okay? Then if there are any nots, you do them next. Then you do any ands, and then you do any ors. So brackets are done first, then the nots, then the ands, and then the ors, okay? So like I say there, while brackets are technically not an operator, you do have to do them first. So I've put them in here. Okay, so here are some examples. So what I like to do is I like to put brackets. I like to insert my own brackets. Okay, so here in this example, you can see it says A or B and C. We know that and comes first. Remember BNAO, B-N-A-O. Okay, we've got no brackets, but we do have an and. So I then put brackets around what I must do first. So I have to do the B and the C first, and then I can OR it with the A after that. Same thing with example 2 here. I have to do the ands first. Okay, so I put brackets around A and B, and I put brackets around C and D. So I know which parts I have to do first. Okay, same thing here, A and B and C or D. Okay, because you've got two ands, you can do them in any order you like. You can do the ands in any order you like. It doesn't matter. Okay, so you can see I've done A and B first, and then with and C, and then I do or D last. Here with the nots, okay, the not A has to be done first. So I put brackets around it. Then I put brackets around the and, because that must get done next, and or C. Okay, you will get used to this as you are going through it. Okay, so I've put some exercises here for you to practice on. Okay, the only one here that might look a bit weird to you is this one here that says length 100. The length, okay, is a Java command that returns the length of this string. Okay, so don't let the fact that it says 100 fool you. You need to count the number of characters in here, including space bars. Length is going to give us the length of that string. Okay, that's what length does for us. It returns the length of that piece of text. So like I said, the fact it says 100, don't let that fool you. Count the characters, including any space bars. Okay, you do not include these inverted commas here. You don't do that. Or this one here. Okay, it's just what's in between the inverted commas. And we are checking to see if the length of that is 11. Okay, and here we are saying that 10 times 5, remember in computer, a star is times, okay, and a slash is divide, because there's no divide and there's no times on the keyboard. So I give you what A, B, C, and D, and E are, so you need to work out, first of all, if these are true or false, and then you plug the true and the falses in here, and you solve the complex equations. Okay. Remember, not, that exclamation mark is another way of writing not. So I could write the word not, or I could put an exclamation mark. Okay. That there is an and, okay, ampersand, ampersand, and that is an or. 2 vertical bars is an or. Okay, so there are some examples here that you can use to test your knowledge. Don't overcomplicate it, guys. It's easier than what you think. Just remember the order in which you must do things, and don't be scared to put your own brackets in, okay, so that you sort out for yourself what order you are going to do them in.